Hi. The question is, a wire of resistance is R is stretched till its radius is half of the original value. Then find the resistance of the stretched wire. Before starting a problem, we have to understand the concept that the volume of the wire remains the same before and after stretching. So we have to find the ratio of the lengths before and after stretching. If volume V1 remains the same, then we have to write V1 equals to V2, and the volume is area into the length A1, length 1, A2 into the length L2. If we rearrange the expression, we'll find the ratio of the lengths as L1 over L2 equals to A2 over A1, and we know that area is pi r square, so pi r2 square over pi r1 square. As mentioned in the expression, the second radius after stretching becomes a half of the previous radius, so we can find the ratio of the lengths as r1 by 2 square over r1 square, and the ratio of the lengths L1 over L2 becomes r1 square over 4r1 square, and the ratio is L1 over L2 equals to 1 by 4. Now, by using the resistance formula, we can find the change in resistance of the wire after stretching, as the expression of the resistance is R equals to rho L over A. If this is the resistance R1, length 1 and area 1, and the resistance R2 is rho L2 over A2, and the ratio of the resistances R1 over R2 is rho L1 over A1 over rho L2 over A2. If we rearrange the expression, the ratio will become R1 over R2 equals to L1 A2 over L2 A1. Now we have to put the value of L1 over L2 from this side. We already find the ratio of the lengths L1 over L2, and by putting the formula of area we can find the ratio of A2 over A1. So L1 over L2 is inside the parenthesis, and the ratio of the areas is again pi r2 square over pi r1 square. After cutting and by putting the radius values, the ratio will becomes r1 square by 2 divided by r1 square, as you already find the value of the radius r2 equals to r1 by 2. Now on putting the values, L1 by L2, this is the whole square, so this will become r1 square by 4 r1 square. The ratio of the areas is 1 by 4, and the ratio of the lengths L1 over L2 equals to 1 by 4. Now put the value of the ratio of lengths L1 over L2 is 1 by 4, and the ratio of the areas is again 1 by 4. Here R1 over R2. If we rearrange the expression here, R1 over R2 equals to 1 by 16, and R1 equals to R2 by 16, and we can write the final expression as R2 equals to 16 times of R1. So we can conclude that the resistance of the wire increases to 16 times the previous resistance.